already 5:01, so we need to start our workshop for today. Hi guys, hope you're all doing well. Happy Tuesday. Welcome to our session with Shopee Code League about basic concepts on natural language processing, text classification, sentence embedding, and name entity recognition. My name is Pash, and I will be your instructor or workshop facilitator for today. Okay, so quick introduction from me. I'm Albert. My nickname is Bash. I'm currently based in the Philippines, and my interests are physics because I am from a physics background. I do artificial intelligence and machine learning for my main work as a consultant for various companies. I also love cryptography and ciphers, and I also do some robotics, so Internet of Things, Raspberry Pi, Arduino, those kinds of cool things that we need to learn for the future of work. And I'm also an activist based in the Philippines. So I use the things that I do to make technology serve the marginalized, serve the oppressed in the context of what problems or social problems we have here in the Philippines. If you want to connect with me, here's my LinkedIn account. If you want to partner with me with some social good or social impact problems, I'm really willing to help. So connect with me through LinkedIn. If you have questions outside of our workshop with regards to how you plan to use natural language processing for your submissions, feel free to contact me. Visit my GitHub account as well for the projects that I do. Most of the things that I produce is open source, so it's freely accessible. The source code is there, so please visit it. And I complement those code with an article on my GitHub page account. So visit alberthumo.github.io for my articles and blog posts. Okay, so aside from my occupation, I also teach part-time with a data science bootcamp company based in the Philippines, but it was originally founded in Singapore. It's called Esquelabs. So Esquelabs is an online data upskilling school based in the Philippines, driving social mobility in the future of work. So it's really like in line with my activism that we use data skills to really empower people, to help them move through the social ladder and really make use of technology to serve their purposes. Okay. So in SQL Labs, we have two types of clients. We do boot camps for individuals, helping them for social mobility, but we also accompany and support companies through business-to-business workshops. So we provide trainings on data analytics, applications of machine learning into their business and use cases. We have a new product that we offer to those who would want to learn as fast as 2 weeks. So we are developing a new kind of pedagogy or way of teaching wherein we let our students learn through playgrounds, through project-based learning. So in a span of 2 weeks, they will be able to produce cool projects already. So we call it the data club. So it's a visual upskilling experience and it's hands-on laboratory, and the students are guided by industry mentors to build data projects that they can already directly use on their portfolios. Here are some of the topics that we have introduced recently, and we have piloted the program already. We teach interactive data visualization with Power BI, what if analysis optimization, creating pipelines for exploratory data analysis with Python, automating the boring stuff with Excel and even Python. I did a class 2 weeks ago about object recognition and also dynamic visualization using running bar charts and even Dash and Bokeh. So we also do data strategy, data governance frameworks for businesses, and we also do customer segmentation analysis. I hope you can hear me. Um, yeah, there's this audio background. Let me resolve it for a minute. Okay, I turned off my AC, so I hope that's better. So I think we can begin. Um, okay, so before we start, let me clarify the objective for this workshop, guys. So this is a code along workshop. So I think we have instructed you to download Anaconda, in particular Jupyter Notebook, so you can type along with us later on in the code along session. Okay. But if you don't have Anaconda right now, it's okay. You can make an account with Google Colab. So go to your browsers, type Google Colab, and make an account. So that also works. But I prefer that you have your own environments in Anaconda already if you plan to use this long term. Okay? So before we proceed with the actual cool stuff and applications of this like text analytics, I think it's very important for us to have a baseline and core fundamental knowledge first of the natural language concepts or natural language processing concepts. So before we delve into really like programming and applying these concepts hands-on, I think we really need to study the basic concepts first, okay? And what's the best way to study basic concept is to study history. Okay, so during the 1950s and 1970s, the interface that we do to communicate with computers are the punch cards. So I think my parents and grandparents were able to see this back then. But the computers back then used punch cards to input and encode information and data. So it's very rudimentary back then. During the 1980s, a lot of the programming languages were developed. So that's like an improvement of how we interfaced with our computers. And today, we are, I think, more advanced, but there's still a lot of like milestones to go. But we're already able to utilize semi-intelligent systems such as these kinds of things. So your Google Assistant, your Siri, and those kinds of things. Some of the applications that we have with interfacing verbally with computers are speech recognition, language analysis, dialogue processing even. So information retrieval through audio means and text to speech to like automate encoding of meetings and so on. So even in the early 2011, an IBM computing system named Watson competed against the world's best Jeopardy champions and won. So I think we are at the level already that we are able to do machines that are smart enough for certain applications that we have, and that's really amazing. Okay. Some of the applications of natural language processing now would be like question answering. I remember when I was in high school, I didn't use Google back then. I used ask.com. I'm not sure if I'm that old, but I think some of you were able to use ask.com as well before. So it's just like a platform, a search engine wherein the format that you need to type in the browser is through questions. It's easier for the algorithm to answer if the format of your text is through a question. Okay. So interestingly, these kinds of things are really relevant in our society right now. So last year, I had a class with my students at the onset of the pandemic because a lot of the areas here in the Philippines are low penetration, meaning a lot of the students don't have access to internet. So we try to develop an app through natural language processing to help the students learn like basic science, basic mathematics concepts, and through a chatbot that we developed using web progressive applications. Those kinds of technology don't need internet for people to use. They just need phone signals. So I think that's really like a good application of NLP that we are able to like help students in terms of their learning because a lot of people are coping hard with regards to how the pandemic is shaking up the norms of how we do our processes and systems. So natural language processing is also relevant in terms of machine translation. So if you're processing multi-language, so it's easy to convert if you know the processes and the basic concepts of NLP. And in general, here are some of the applications of NLP, and in conjunction, the core technologies needed to study these things. So we do machine translation as I would have like showed you a while ago, information retrieval, meaning if I want to get specific information from a prose or from a text, question answering, what we demoed a while ago, question dialogue systems, information extraction, summarization, meaning if I don't want to read a book, for example, I have this book right here. I'm too lazy. Like remember that good programmers are lazy programmers because they always want to automate things and use machine learning and things like that. So if I don't want to read a hefty book, I just need to like apply good enough summarization algorithm with NLP to summarize the text for me if I like would want to read more about it. Sentiment analysis is also relevant for companies right now because we are at an influx of big data. There's so many information in Twitter, in Facebook, in Reddit. So even if you're a company, you have a company page, you would want to analyze the sentiments of your customers in terms of your products. Again, in Shopee, it's really like relevant because if you want to get the customer reviews for a certain product, you can definitely use sentiment analysis to find gaps in your service and so on. So my key takeaway for this slide is that NLP lies at the intersection of computational linguistics and machine learning. So you don't need only machine learning when studying NLP. You also need to understand the basic concepts in computational linguistics. So it really goes hand in hand. You cannot really let go of the other, as we will demonstrate later. So in terms of computational linguistics, you need to review your basic grammar, your basic English. Why English? Because, colonialization. English is like the most common language that we use to like communicate to other languages as well. So I think that's a fair way and a reason why we use English as our main syntax and um, doing NLP, but yeah, it's mostly colonialization. So in terms of the level of linguistic knowledge, here are the topics in linguistics that some of these topics are harder to implement with NLP and some of them are easier. For example, speech, it's easily like translatable to text. The phonetics, the sounds, the phonology, the orthography, the origin and the spelling, how we spell the words. It's easy to understand mathematically, right? We can make equations to represent these things. So it's easy to do that. But in terms of semantics, so looking at the meaning of words, pragmatics, looking at the truth and the facts of those discourse. So that's a little bit difficult because you're really like teaching your algorithms, the environment to do it and to figure it out, the context, and that's really hard. Okay, so we will try some of the shallower topics here. So for example, lemmatization, morphology, phonology, we will dive on it in a while, but we will also look at the semantics and how you will be able to use it to your advantage. So in terms of phonetics and phonology, um, it's easy because I think it's common to all languages that we have these diphthongs, this process of how we pronounce our words, and we call it pronunciation modeling in natural language processing. Um, Aside from phonetics and phonology, we also have uh, language modeling through tokenization and spelling correction. So tokenization is really vital to how you do um, natural language processing. What it means is that if you have a sentence, if you tokenize it, you just get the individual words. So for example, this sentence, this is a simple sentence. If I want to tokenize it, I will just get in the individual words in that sentence. Okay? So that's tokenization. Morphology, on the other hand, would be looking at the different forms of a word. So for example, in this sentence, this is a simple sentence, is can be written into other forms depending on its tense. Is it like the present tense? So can it be be? So for example, if I change the word sentences, so what's the root word, for example, of sentences? So it's just sentence. Okay, so it's looking at the root of the word and its different translations into different uses in terms of tense. Okay. Another important concept in NLP would be part of speech tagging. So again, this is very important to review your basic English grammar because you need to identify, okay, is this word here a determiner? Okay, is this word here a verb? Okay, is this an adjective? Is this a proper noun? And so on. Because by teaching the computer those tags, it will be easier for it to represent it mathematically and to process it efficiently. I'm reading some of your comments already. You don't need to really like get the source code because this is a code along. So definitely if you follow along the class, you will get the code at the end eventually. Okay, so in terms of syntax, this is very important if you would want to know the meaning. the structure of your sentence. So for example, if I would want to get the subject of my sentence, what if I want to get the noun phrase of the sentence? So things like that. So we call it dependency parsing. The way you connect words and find the best connection to represent the meaning that you want to convey. So it's called syntactic parsing. Okay. So in terms of semantics or finding meaning in a sentence, these are some of the concepts that we use. Um, Named entity recognition, for example. So if you want to get, for example, important details in a sentence, for example, what's a good example? We landed on Mars. So for example, I want my algorithm to capture that Mars is a planet. Okay, so that's named entity recognition. For example, um, Apple is suing Facebook. So the algorithm should understand that Apple is not a fruit, but it's a company. So things like that. Word sense this ambiguation. So for example, if I have two words in English, they are the same words, but they mean differently. For example, the word L-E-A-D. So it can mean lead. So for example, I'm gonna lead you this way. Or it can be led, so the element in the periodic table, and similar kinds of examples. Um, yeah, we will demonstrate later as well the acronyms for the coding part, but you don't have to know it right away, but later we will demonstrate it. Okay? So next would be the discourse. So we also would want to let our algorithms or even NLP processing, for example, if you want to apply this to a chatbot, to intelligently reply to previous sentences. So for example, if I have a sentence, this is a simple sentence, I would want my algorithm to have a smart response to it. So for example, if I want to have a contrast or an interjection, I can reply, but it is an instructive one. So things like that. So the discourse basically is for us to know the fluidity of conversations. We are mimicking the fluidity of how we talk to each other. Okay. So in terms of what we are now, I really would recommend you guys to watch this movie called Her. It's about a writer. He bought an artificial intelligence system to help him write. But then again, he noticed that the AI or NLP model that he was developing was really like smart and was able to develop like emotions. And the guy fell in love with the AI algorithm. So that's really like romantic in a weird way. But yeah, I think we're not yet there, so it's still science fiction, and I think it's part of a singularity that will be like far, far, far from the future until we achieve that kind of technology. But right now, most of the algorithms that you see, for example, if you look at local businesses in Facebook and they have a chatbot, most of those chatbots are rule based. So rule based meaning if you input a sentence, the algorithm will just find keywords in that sentence and use that keyword as a reply. So it's not really simple because it's just like looking for keywords, right? But some algorithms are are smarter. They use probabilistic and statistical models to find based on experience what would be the best reply from this question from the customer. So that's where we are right now. So another like cool technology that Microsoft um, did last 2016 is Tay, the chatbot that they operationalized in Twitter. So they took down the Tay within like less than 24 hours because it was spewing racist comments. So yeah, that was really like a problematic thing. So again, hand in hand with technology, it's really like important that we consider the ethics of the technology that we use. So one of the things that I always say is that when we build technology, we need to build it as an extension of our humanity, because at the end of the day, the users of the technology that we build that we will build would be humans. So it's important. So there are also like cool algorithms out there, but it's not yet too accurate. For example, if you have a picture, and then you can have your NLP describe that picture. So, for example, in this, like, the woman is not necessarily cooking, but it's just like washing hands. So they're like this was way back in 2017, but I think there are newer models like BERT and even GPT-3. who was like able to like produce better outputs from this one. So this is a commercial. This is a misplaced slide, but I just want to point out that how do computers understand language is basically mathematics. So, for example, I have a word here. I mean, a sentence. I will just tokenize it, meaning I will get the individual words and then represent it into vectors or mathematical numbers. Okay, so it's as simple as that. And where do those numbers come from? It's just a training set. So basically, you expose your algorithms into like training sets like a Bible, like a book, or even data set from Twitter or Facebook to learn and assign those numbers for you. Okay. So again, before we proceed, we need to understand why NLP is hard because based from my experience in the industry, not a lot of companies would really want to use NLP off the bat because it's not really like useful for them to, okay, give me the most common like word. I hate word clouds, but it doesn't tell you a lot like what's the most frequent words. It's really like hard to like make sense out of in terms of like business. And this 7 items here like identifies why NLP is hard to apply into like business context. Oh no, I hope you can hear me, but I think some people are having problems with their audio. Okay, let's start with ambiguity and scale. Okay, so I already mentioned this a while ago with regards to the problem of ambiguity and scale. So, for example, if we're trying to make sense of the word, so bank can either mean finance or a river. In terms of parts of speech, chair can be a noun, chair can be a verb, right? So, for example, I'm sitting on a chair, so a chair is a noun. I want to chair this program, so chair is a verb. So it's really like ambiguous in that sense, right? So, for example, this sentence as well, I can see a man with telescope. Am I the one using a telescope or am I seeing a man using a telescope? So things like that. So that's a problem with ambiguity. There's a question here from Sushat. If some words are misspelled, does it affect tokenization? I think not, because tokenization only like off the bat, it just look at white spaces. So as long as it is like on its own, like separated by white space, then it's just a single word. Okay. This workshop contains coding, by the way, but it's at the later part of the session. Okay. So, for example, another example here would be one morning I shot an elephant in my pajamas. So, shot can mean like I would like shoot an elephant, or maybe I will take a photo of it, or maybe it's just a figure of speech. So, things like that. So in terms of scale, on the other hand, if you look at different models in your NLP pipeline, English, for example, we have so many training data set. And as you can see from the y-axis, this is the level of difficulty in terms of how we can apply NLP off the bat. So for example, lemmatization is easy, part of speech tagging is easy, NER is easy, but if you go along this axis, you will find that these technologies are harder to implement. Okay. Um, Also, NLP is hard because of the availability of data set. Um, for example, there's not a lot of language focusing on Filipino. For example, it's hard for us to do chatbots in Tagalog or in Filipino because there's not a lot of data set. So it's all about an issue of scale and ambiguity. Okay. So here are some of the challenges in words to highlight some of the discussion points that we had a while ago. So the problem is segmenting text into words, doing morphological variation. For example, if I want to compress a word into its root word, doing words with multiple meanings like bank and mean, domain-specific meanings, and multi-word expressions. Okay. So for example, if you get data from Facebook, for example, you might like find this kind of text like IKR, SMH, he asked FIR, yo, last name. So it's hard even for me to like understand this. Uh, but yeah, we need to teach our computers how to comprehend these kinds of variations of the natural language that we use. Remember that formal language is different from natural language. Natural language is what we use to convey naturally, because natural language, admit it, guys, even in your own local language, you use a lot of wrong grammar. Like even me, like when I'm like using Filipino, I admit that, okay, that's the wrong grammar. um, so, for example, we need to make our algorithm smart enough to recognize that IKR is I know, right? SMH is shake my head, and so on. So these kinds of like concatenations and even acronyms and so on. Okay. Aside from identifying that, we also need to teach our computers to identify the part of speech relevant to that particular corpus or set of documents. So we need to identify, okay, is this phrase here, is it an interjection? Is it a pronoun if it's a word? Is it a proper noun? And so on. So things like that. So another thing, you should also consider how your algorithm would um, squeeze out syntax. For example, if I have these two semantic layers, natural language processing, the first one focuses on the word processing as a noun, and the second one focuses on the word natural as an adjective. So for example, natural language processing, so I'm focusing on the noun as NLP as a discipline, so it's a processing technique, as compared to the other one, which is natural. So I'm focusing on an adjective describing that the language that we are processing is natural and not artificial. So again, my point is, it's important for us to really understand the context and the morphology of the words and the syntax that we will try to implement in terms of how we develop the algorithms. Okay? So in terms of semantics, semantics is just the meaning of sentences, of words. So for example, if I give you the sentence, every 15 minutes, a woman in this country gives birth. So you have some preconceived notion of what it means already. It's some form of like statistics, it's some form of research. But then again, if I add something to that sentence, would your perception be different in terms of its meaning? So for example, let's take a quote from Groucho Marx. Our job is to find this woman and stop her. So that's his statement back then. So definitely from a neutral statement, it becomes somewhat negative. So that's semantics. So the connection of words into each other and how we can try to define and ooze out meaning from it. Okay. So again, this is the example that I was like showing a while ago. So we saw the woman with the telescope wrapped in paper. So this causes ambiguity. So to solve that, we really need to understand semantics and syntax together. So who has the telescope? Um, who or what is wrapped in paper? And is it an event of perception or an assault? Okay. So how do we deal with ambiguity? Some of the algorithms that we use for it includes these things. We use non-probabilistic methods, so you can research on it, CKY parsers for syntax. It returns all possible analysis of the sentences based on a dictionary. We also use probabilistic models such as the HMMs or the hidden Markov models for POS. We also have PCFGs. These are probabilistic context-free grammars. So one of the common algorithms that we also use would be like Viterbi algorithm, which is very similar to how you do hidden Markov models. Okay, don't worry if these terms um, like bug you. These are just the things that you need to like know in hindsight. But luckily, there are already like libraries that we can use in Python that are off the bat can use this algorithm. So it's just like off the shelf, we can apply these algorithms already. So another definition that I need to highlight would be the concept of corpora. So a corpus is a collection of text. So that's what we use to train the words. Okay. So if I will let you download a sample training model for an NLP later, and you will see how it's constructed. But it's similar to a dictionary. It contains like a lot of words, and those words contains different meanings depending on how it's used. For example, if is it used as a noun, so how is it defined as a noun? Is it used as a verb? then how is it defined as a verb? So things like that. So it's similar to, I was lucky last year that not last year, this is way back. I was able to visit the British Museum, the Rosetta Stone. You can really like see how this natural language inspired these algorithms. It's like a reference file that you can cross correlate. Okay, I want to apply machine translation. So I need to have a reference in English. I need to have a reference in another language that I want to translate and another language that I want to cross reference. So it's similar to something like that. So statistical NLP, on the other hand, as compared to rule-based NLP, uses probabilistic models. Okay, so it's robust compared to rule-based method, and it uses a lot of training data set to learn from data. Okay, so that's the discussion for sparsity. We go to, that's the discussion for ambiguity and scale. Now we need to shift to more mathematical and rigid concept of the problem with sparsity. Okay, the problem, if you're given a book, if you will analyze all of the words in this book, you will see a problem. Okay, the problem is that if you count the frequencies of the words, if you're doing a model of the book, you will see that most of the frequent words are noise. They are not relevant. For example, in this book, you see that, okay, there are 1,698,000 words that are the, of, to, and blah, blah, blah. So you really don't need this words. No? We call it stop words in NLP, and we usually need to remove this to highlight the more important words in a corpus or in a text document. So all of these things follow what we call the Zipf's law. So the Zipf's law is states that given a large number of data, the frequency of the words is inversely proportional to its rank. So what do we mean by that? If you have more occurrences of that word is irrelevant. The more irrelevant that word is. And if you look at the mathematics behind it, you will see that it's a power law distribution. So again, if you're a budding data scientist, you would love to really be good in your field, or data practitioners, study power law distribution because it appears a lot in nature. It appears a lot in the industry, even the waiting time for your orders in Shopee. If you model the distribution, it's usually the power law distribution. So it says that the frequency, again, the frequency of the words is inversely proportional to its importance or its rank. Okay. So again, this is very universal. It's not only for English. If you look at the mathematics behind other languages such as Spanish, Finnish, and even German, you will see that the same trend follows. So this is true to, in a universal sense, other languages as well. Okay. So in terms of variation, suppose we want to train a speech tagger or a parser on Wall Street Journal. Would this like well-constructed sentence, this model that we use to analyze a well-constructed sentence, still be applicable to a sentence that is what we find in the real world, like this one? So you need to consider those kinds of things, right? And in order for us to resolve this problem of applying a general model, remember this, it's the problem of the scientists. They're looking for a general formula that can be applied to as many possible scenarios and environments as possible. So it's similar to what we're doing here. We're looking for a model that can be applied to clean sentences, like well-constructed sentences, and a model that can also be applied into noisy sentences. So to solve that, we introduce a new dimension in terms of how we use our technologies. We introduce the concept of big data, of web scraping. So we get corpus or training models from the Bible, from our laws, from the parliamentary models. Wikipedia is a good training model. Most of the things that I use in my work is from Wikipedia and even the Twitter API and so on. So here's how you can resolve the generalization problem and the problem of variation. Okay, just introduce more data sets from it. Okay, so in terms of the last three components, expressivity, unmodeled variables, and unknown representations. For example, this is the inverse of the concept that I told you a while ago. We have two words that are the same, but they have different meanings. This time, we have two different sentences, but they have the same meaning. So for example, she gave the book to Tom versus she gave Tom the book. It's basically different order, right? But for algorithm should be able to understand through adjacency of words that they are just the same in terms of syntax. Um, the other one would be the unmodeled variables. This is really hard problem that I even encountered when I was in physics in terms of doing simulations of the universe. So how would you teach your NLP to learn the dynamics and the systems, the equations of the real world? So for example, if I have this sentence, I dropped the glass on the floor and it broke. What is it? What broke? Is it the glass or is it the floor? Okay, who is telling me that in this like world that we're introducing the algorithm, a mouse is smaller than an elephant? So there's nothing stopping us into like having those kinds of assumptions, but it should be explicit in our models what worldview or what world knowledge we are introducing these algorithms. And then this is just like mathematical, like how do we define meaning? It's always the controversy when we present natural language in our thesis, like people, how do you define meaning like in this context? So it's always philosophical as well. And there's this like part of NLP that's not yet well developed. It's still experimental. It's really like interesting to work in NLP right now because we are at a state of the art and at the forefront of this technology. A lot of still is like experimental and changing. Okay. So desiderate for NLP models, what do we need from NLP models? Because there's a lot of problems in terms of how we use it. Again, one problem is sensitivity to a wide range of phenomena and constraints in human language, because human language is ever changing. Some terms would be like hyped right now, like in the terms that they use in TikTok, that we need to like update our dictionaries to accommodate those kinds of words. We also need to generate it across language. So meaning we don't have to necessarily just develop something for English, but maybe develop more robust models for other languages as well. We should have strong formal guarantees in terms of how we represent word embeddings, or meaning how we use mathematics to represent the words. And of course, to develop a highly accurate model that can be used into our cases. And of course, the important thing is veracity, meaning the ethics of the NLP models that we have, because some of this might be used in deep fake, some of this might be used in generating fake news. So we already saw a lot of these algorithms like contributing to the noise. So again, I believe personally that these kinds of technologies as a dialectic tool, it can be used for good, as we've seen from the various applications, but it can also be used for bad. So as people who's like involved into this kind of technology, we need to be the gatekeepers of how this technology should be used collectively. Okay. So just a comparison of the symbolic versus the probabilistic NLP developed before. So before we're using rule-based. So for example, if this keyword exists, then output this sentence and so on. On the other hand, if you use statistical NLP, we use probabilities. Okay, but this is not how we do it now. What we do right now, starting like mid 2010s, we already used the concept of neural networks. So taking inspiration from our human body on how our neurons transmit information from the dendrites, from the nerve endings up to our brains. So it's really like fun. So here's a typical pipeline of how we use NLP, in particular the chatbot that I had my students build before. Normally we get data, training data from Wikipedia, and then we apply some machine learning algorithm to process it. And then after processing with machine learning, we apply statistical model to do word embeddings or to represent the words into vectors or numbers. And then after doing the statistical models, and then we apply the operations that I was referring to a while ago. Okay, so this is a comparison of an implementation that we will try to do later on Spacey and in Python. So this is your, for example, a comparison of how we do it with artificial intelligence and neural networks, and how we do it previously using programming code. So back then, during the 1980s and before that, most of the NLP algorithms are just if-else statement. So it's just a if-else, 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 if-else. So just rule-based, like exhausting all of the possibilities. So it's really inefficient, and it's really like intensive in terms of like computing capacity. But now through neural networks, it's optimized. So this is the current state of the art of how we do natural language processing. We use neural networks to process it. So for example, we first apply word embeddings to a sample sentence and then apply LSTM, recurrent neural networks, or even the algorithms made recently by Google like PERT, GP3, and so on to identify the distribution of words and what would be the probability of this word being a verb, this word being a noun, and so on. Yeah, so we combine concepts that we borrow from engineering, such as convolutions, and use it as our hidden layers for the models. But don't worry about these things. This might be too difficult to understand right now. But I hope you will be like, just be familiar with the terms, because later on, if you continue using NLP, you will definitely be in touch with these terms again later on down the line. So a quick difference between NLP and linguistics. NLP must contend with natural language. So it's important that your algorithm is not generating its own language. It should really conform and contend to what is seen in the real world. Okay? So NLP should be computational linguistics that is applied to reality. And then um, linguistics has begun to use tools originating in NLP, because previously linguistics people they use very crude technique in terms of how they understand language. So right now with the tool of big data, with the tool of machine learning algorithms, we're able to like help them and even use these things in other domains and business cases. Okay, so if you can take a screenshot, here are some of the fields that we apply NLP right now. So a lot is of course through like machine learning, understanding human language, cognitive science, brain networks, information theory, your Shannon entropy, and how information is never created nor destroyed, logic, data science, political science, very relevant right now because we use a lot of NLP in terms of campaign propaganda. If you want to target certain demographics of people, because most of the campaigns for political efforts right now are done online, right? So it's really like important to apply NLP to computational propaganda in politics. Also use it in psychology, economics, and even in education. Just to add here some of the other applications that we use. I already mentioned some of it a while ago, but here are some of the applications that we use as well. So some of the part-time jobs that I do, I use NLP to process law documents, to process and to like streamline searching keywords that would be relevant to a case. So things like that. Factors changing the NLP landscape right now. So it's really like rapidly in development right now. Even the libraries that I am using, I was retyping my code earlier and I saw that, oh, the library was updated, so my code is no longer working. So I need to update it because it's constantly changing. So again, the mindset here is to always be open to like learning new things, because this is an active field that you would be engaged continuously. So there are a lot of developments in machine learning as well that complements NLP. And in terms of the current research that we have in terms of human development, there's so many models that we developed recently through improvements in research. Okay, so okay, I think we need to proceed with the actual coding for this workshop. We will be using Spacey. So it's a good library in Python. Here is a sample pipeline that we will try to do in Spacey. We'll do tokenization, we'll do lemmatization, we'll do tagging, parsing, and entity recognition to help develop a pipeline that you can use to study sentences and even words. Okay? Okay, so it's code time. So before we proceed with the code time, I need to take a water break. And you guys should start opening your Jupyter notebooks already. So I hope you were able to figure out how to install Anaconda. So if you're able to do so, give me one moment. I'm gonna share another screen. Share another screen. So if you open Anaconda, you will see this interface. Just click launch in the Jupyter notebook. Okay. And it will pop up a browser with a Jupyter notebook on it. Okay. I'm gonna give you like around 2 minutes to open your Jupyter notebooks. So if you're able to open your Jupyter notebook and click on it, you will see something like this one. Okay. So this is the interface of Jupyter Notebook. I think some of you are already messaging me that you're familiar with this already. Let me just increase the size. Okay. So again, the tools that we will be using for this workshop is Python and Spacey. Okay. And let's just wait for the others to pull out their environments. You guys take some break as well. Like be mindful of your like environment. Move away from your screen. Drink water. Stretch. Okay, while waiting for some of you guys to finish it, we will not be doing sentiment analysis for this session. I do want to remind you guys that this session with us today is a two-part workshop. Yeah, you can also use PyCharm, by the way. You can also use that. This is a two-part workshop. For today, we will be discussing basic concepts in NLP. So that would be text classification, sentence embedding, and then named entity recognition. Next Friday, I think that's 7 p.m. Singapore time, we will be doing sentiment analysis and topic modeling. So that's the topic for next Friday. And definitely word cloud will be included on Friday, but not for today's workshop. So I do hope if you would want to learn more about sentiment analysis, topic modeling, and so on, feel free to attend our free session on Friday. So for those who are using their phone, who don't have like access to like a computer, I know there's this like problem of digital divide. Don't worry, I think we can forward the notebook that we will be producing for today. So you can have your own reference that you can look at as well. Okay, I think we have to start. The first thing that you need to do is to install Spacey in your environment. So to do that, we need to colon bash command. So you need to like pip install Spacey. So again, I would recommend if you can split your screen, like half would be the Zoom call and half would be your Jupyter notebook. So you can type along with me. So this line of code here, we're just using pip to install the Spacey library. It will install the latest version of Spacey. And then don't run it yet. Type Python -m Spacey download. We will download the library that we will be using. So N core, what's this? Web SM. So core English library from the web, small. So we don't need the like the large one. Well, if your internet is good, but I suggest don't run it. You can also like try to download the bigger one. So you can try to download the bigger library. It's called LG. So large. Okay. So I suggest for the first run, comment it out. So to comment a line in Jupyter Notebook, just place a hashtag so it will not be run by the cell. So you can do that. And then press Shift, Enter, or whatever, and let it like finish installing and so on. So give it a few minutes because it will have some like time to finish. So mine is fast because I have already like installed it previously. Okay, for those who have really like fast internet, it's not the case here in the Philippines. We have very slow internet. You can also try to download the bigger one, but this is big. It's around like 800 MB. So I suggest not running this like last line here because it's big. But since I am brave, I will run it. Okay, just type in these 3 lines. No, just these 2 lines. But for those who have fast internet, include the third line. Okay, so it's done running. So I hope you guys were able to like run it as well. We'll give some lead time for the others to finish downloading, but I think we need to start discussion already for the other segments of the code. So the first thing that we need to do, again, hashtag means a comment in Python, would be to deal with the imports. So I just need one library to import, and that's Spacey. Okay. And then after importing the library, what I need to do is to load the library or the dictionary that you just downloaded. So let's call this variable NLP is equal to, let's call in the library spacey dot load. And then we call in the library that you downloaded. So if you're able to download this one, then use this one. So copy it and then put it here. Okay. But if you're able to download the bigger one, then that's better because it contains more words and training sets. So that's better. But this one will work already. Okay. So I just need to copy this one. So this line is for uh, not so fast internet. So this line here, I will replace this LG very fast internet. Okay, since I have fast internet, I'm gonna use this one. I'm gonna use the second one. I'm gonna comment this out. Okay, and if you're done typing this one again, we just need to import Spacey, and then we need to load the model that we will be using. In my case, I will be using LG. For some of you, I think most of you, you can already like just use SM. Okay, so then Shift Enter, let it run. It will take some time to load the big library. Just give it some time. Yeah, I think we can have some arrangements as well to give the code to you guys after the session so you can have some reference. But definitely, I can upload this code to my GitHub account. So I can just give you my GitHub account later so you can download the code there already. So it's easier for us to access it. Okay, so I hope you were able to follow. Just a quick recap of what we've done. We've installed Spacey and the libraries. Huh, okay. We installed Spacey and the libraries. The next thing that we need to discuss is what we discussed a while ago, tokenization. Tokenization. So what does tokenization means is that if I have a sentence, I want to get the individual words of that sentence. Okay, so for example, let's make a sentence. So to make a sentence, you define a variable, any random variable, but for this session, let's call it doc. And then let's call in the model that we've used, NLP, and then type in, for example, the sentence, I am flying to Manila. For example, I have this sentence, okay? If I want to tokenize this sentence here, what do I need to do? So if you're familiar with list comprehension with Python, you can just print. Well, let's make a list. And then let's try to extract all of the words in this sentence. How do we do that? Type in, let's say we're extracting words as W, so W dot text for W in doc. So if I type in this code here, shift enter, basically I'm getting the text of all of the words in doc. So as simple as that. So you can see the output is the individual words of the sentence, including the punctuation. So the punctuation is included because this is very relevant in terms of semantics later on, right? If you have a question mark, if you have an exclamation point, that's important to extract meaning from the sentences, okay? Okay, I'm gonna take a pause for you guys to have like some leeway time to copy the code. Again, first, this cell here is just importing the library that we're using. Second line is loading the dictionary that we are using. And then for the tokenization, we define the sentence using the dictionary that we had, and then using list comprehension in Python to extract the text of the sentence doc. Okay, so I think most of you were able to follow along. That's good. So the next part that we need to discuss would be lemmatization. Lemmatization. So again, lemmatization, what's the meaning of lemmatization? It's basically getting the root word of a word. So for example, if I have the word sparks with an S, I want to get the root word of that. So the output should be just spark, okay? So again, let's define a new sentence. Let's call it doc. Let's call it doc, and then let's define a new, not really like a sentence, even just a phrase. Okay? So for example, this product integrates both, so space is the product, both libraries, libraries, where's my mouse? For downloading, just inventing sentences. This product integrates both libraries for downloading and, let's say, applying patches. So I am including words that have added extra words in it. So for patches, applying, just apply. So if I have this sentence, if I want to apply lemmatization, space is really handy. It contains all of the things that you need to do NLP. So I can do a for loop, for example, for token, or for the words in the document, in the doc. I can print the token.text, or the token.text. So these are the individual words. So token.text, and then token.lemma underscore. So if you do this and type in shift enter, okay, you will see that on the first words in the list, it contains the text or the words of this phrase. The second, on the other hand, contains the lemmatized version of that word. So that's the simplified version of that word. So for example, integrates is just the root word of integrates is integrate, libraries is library, downloading is download, applying is apply, patches is patch. Okay, it's really important to declutter the words because it's easier for the computers to understand if it's at its base form. So that's why it's important to lemmatize the words. Okay. Okay. So I think I'm gonna give you some few more minutes to like copy in the code. But again, you can just try any sentence or phrase that you would want to test out. Feel free to modify it. Okay. So we're done with tokenization. We're done with lemmatization. I think the next part that we need to do is to do part of speech tagging. Part of speech tagging. Part of speech tagging. How do we do this? Okay, so for example, I have a sentence. Let's define a new sentence. Um, let's say I have flown to Singapore, and then I am flying to Manila. Okay, for example, I have two sentences. Okay, if I want to apply part of speech tagging, it's really as simple as this one. So um, how do I do this? So for token, so for the words in the document, in doc, I want to print token dot text, so just the original text, and then type in token dot pos. So this is the um, part of speech, and then uh, the token dot pos underscore is just a simplified it's like a simple version of the part of speech. It's not yet too detailed. If you want to get the detailed version of the part of speech, you can type in token dot what's this tag. Okay, so if you type this and print it, so you will see that it contains first column here. The first column are the actual words of the sentences that I placed. And then the second one would be like the pronoun. This is the auxiliary verb. Flown would be verb. So that's the part of speech. And then the detailed version is that, okay, it's a pronoun. So what type of pronoun is it? So it's a personal pronoun. So things like that. So if you want to have like a detailed part of speech description, you use the tag underscore. But if you want just the general part of speech description, you use POS underscore tag. Okay. Some of you were asking me a while ago, what does like AUX mean? What does VBP mean? There's a tool in Spacey that is very handy to have those explanations. So for example, if I'm naive in English and I don't recall the word AUX, I can type in Spacey dot explain Spacey.explain and then type in your question. So for example, I don't know AUX. So type in AUX. So it will say, oh, this is auxiliary. Okay, type in VBZ. There's a question a while ago. What is VBZ? Spacey.explain VBZ. VBZ, and so on. So it's a verb, but it's a type of verb that is third person singular present. So you will see the importance of linguistics, right? It's not all about programming. It's not all about doing the code. We need to have a base understanding of linguistics first before you can optimize and maximize your NLP applications. Okay, that's why when I was teaching this, it's like I wasn't an English teacher before I am a programming teacher to my students, because we need to be aligned on the terms. What is an auxiliary verb? What is a transitive verb? And so on. So you need to be like persistent. If you want to continue studying NLP, you need to really like study linguistics. Not the super hard linguistics, but at least workable linguistics or just basic English grammar. Okay, I'm gonna zoom out for so you can see the other codes as well, but I hope you can still see it clearly. Okay, so let me go back to the sentence that I gave you a while ago, this sentence here. Um, the thing is, what if I want to extract a particular verb here? For example, I want to extract VBG. So I want to extract the verb gerund or the present participle. So that is this one. What's the verb in the sentences? This is like flown and flying. So for example, I want to extract the word flying in this sentence. How do I do it? Okay. So it's similar to what we do in text classification and even entity recognition. So to do that, I can do this. So what is the doc? So it's still the same. This is the sentence that we are trying to wrangle. So if I want to get this word here, flying, it's not really easy because there are two words that are similar to fly, right? So for example, if I want to print dilemma, so dilemma, I want to print in dilemma, I will see that, oh no, how do I extract it? Because flown is also fly, flying is also fly. So how can I extract the word flying? So again, this is where like basic linguistics comes to practice. We need to get a certain form of the verb. So to do that, I'll just like show you. So I need to print. Again, we're using list comprehension to do this. So w.text for W in doc. And then you can use if else statement, or you can use if statement or conditionals within a list comprehension in Python. So to do that, so if W dot tag, so the specific tag, I just want to get the verb gerund or present participle, for example. So that's VBG. You can also like have another conditional or an or statement. So you can also just to capture everything that you need. So you can, I'm not sure what's the form of flying. I'm not sure if it's VBG or verb. So what is VB? The base form. Okay, so I can type in just VB. So I'm sure that it captures the correct term. So if I write this piece of code here, I'm getting the text in the document here. That is verb gerund. So this is the form flying. I want to get this word here. So I think I'm confident. Oh yeah, so that's good. So I still have my basic English with me. So you can use these types of tags no, to really extract certain words of interest in your sentence. Okay. Um, what else do we need to discuss? Oh, right. We're doing multiple sentences. Right. So I haven't like include that. So there are like, if you recall, previously we were only like processing single sentence, right? Single sentence or just phrase. But in this sentence here, in this corpus here, like document, we have two sentences. What if I want to analyze them separately, right? So again, this is an application in Spacey that is very convenient. Okay, so to do that, um, what's my doc again? Okay, to extract and analyze those sentences separately, what you can do is to use the sense tag in Spacey. So for, let's check what's the doc again. It's two sentence. Okay, good. So for sentence in doc dot sentences or sentences print. Again, your knowledge for list comprehension in Python is very handy during these times. So sent, what's this? Sent I. So I'm getting the individual sentences in the document for I in how many sentences are in that document. So that would be range and then length and then what is sent. Is this correct? So if I run this one, oh, yun. So it worked. So with this list comprehension, we were able to separate the two sentences from each other, okay, by using this argument here from Spacey dot sense. Okay, it gets it for you. Okay. Okay. What else can we do? Okay. So what if, for example, we are given this sentence, doc is equal to NLP, let's say the Golden Gate Bridge is an iconic landmark in San Francisco. In San Francisco. For example, we have this sentence. Okay. The problem if you have this sentence, for example, if we print, for example, if I'm gonna print this one, for example, I'm gonna print W text or W in doc. If I do this, okay, here's the problem with this type of sentence, right? I would want my algorithm to identify that Golden Gate Bridge is a single entity. It should be like a single phrase and not as separate words. Also, I would want San Francisco, for example, to be identified as um, one phrase and not two words, right? So what we can do, there's a handy library in Spacey called retokenizer. Okay, so to do that, um, let's do this one. Okay, so with doc dot retokenize, meaning retokenization, meaning we're combining separate words together. So that's the meaning of retokenization. So spelling retokenize, retokenize as retokenizer. I'm afraid that I will have some error because of spelling issues. But anyway, the error will indicate what type of error it is. So errors are good. So retokenizer dot merge. And I want to count like what words do I want to merge. So for example, in the document, you can also apply list slicing in NLP, like how you do it in Python. So for example, the Golden Gate Bridge. So I want to start in this with this word up to this word to like combine it, right? So to do that, I need to count it. So remember in Python, we start counting from 0. Okay, so this word here, it's 0. It's counted as 0 position in Python. Golden is 1. Gate is 2 and bridge is 3. Okay, but remember, like counting in Python is exclusive. Yeah, so you need to like add +1 at the end. So therefore, if I want to combine the words Golden Gate Bridge, I need to slice the sentence into 1, 2, 4. Okay, so 1, this is Golden Gate Bridge. Okay, so those are the items that you need to combine. Okay, what else? I also need to retokenize San Francisco, right? So San Francisco, I need to like merge it into one. So I'm just gonna copy this one. Copy this one and then count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, San Francisco 0. Ah, I should. I'm counting incorrectly because this is already one word. Okay, so 1, 2. I don't know. 0, 1, 2, 3, 4, 5, 6, 7. So that should be 7. So that would be 7 to 9. So that's the right index for it. Okay, let's test out. Like I'm interested with the results. So for token in doc, let's print. And I'm for token in doc, let's print token dot text. So the individual words of the sentences, and then I want to get other metrics as well. So I want to get the lemma just to show it, and then let's take the token that part of speech. Okay, so if I try running this one, There you go. Yay, it worked. Relieved. It worked. Okay, so as you can see here, before the sentences were, the words in the sentences were classified as like separate in terms of like the golden, gate, bridge, it's separate. But since we introduced the tokenization, we combined words into phrases that are um, related to each other. Then you can do retokenization. So later on, if you would want to put meaning to the words, it's easy to like say, "Oy, Golden Gate Bridge is a place. Hey, San Francisco is a place," and not San as a phrase and Francisco as a place, a separate entity. Okay, so that's amazing that it worked. Okay, the next thing that I want to introduce to you guys is dependency parsing. That's very important. Okay, so we're now with like word embedding. So dependency parsing. So dependency parsing is what we use to extract meaning or semantics from our words. So for example, I have a sentence. Okay, let's try type it down. So for example, I have a sentence. Doc is equal to NLP. What's a sentence? Give me a sentence. I want a green apple. For example, I want a green apple. Okay. I would want to let my computer know that green is referring to apple. Want is the verb for I. So I need to know how these words are connected to each other. And the technique or the concept that we use to do that is called dependency parsing. Okay. So for example, I want to do that. How to do this? So for loop, so for token in doc, token in doc, what do I need to do? Print token dot text, and then okay, let's also like print other metrics, so part of speech, um, and then what do I need to add? Okay, the dependency parser. So dependency parser, that's token dot depth underscore. And then I want to use spacey.explain to explain the tags because I don't like memorize these things. So spacey.explain, can type it here, and then type in token dot depth. So just to explain the meaning of those dependencies. So if I run the code, so I, for example, so I is the word, the part of speech is, it's a pronoun. The token, the dependency part, it's a subject, it's a noun subject, it's a nominal subject. Okay, it's described here that it's a nominal subject. And the main focus of your sentence is want. Again, if you are planning to do like NLP in the future, the root is one of the most important things that you need to like take into account when doing a chatbot, because it's the intent of the sentence. It's always the verb as the intent or the motivation of the sentence. Okay, so A is just a determiner. Green is just adjectival modifier, and so on. Okay. I think it's hard for us to imagine it this way, but I think it would be helpful if we can graph it. Yeah, let's try graphing it. Okay. Um, Sige, I think we can try to graph this one. We can, okay, I'm gonna teach you a bonus technique so you can like see it, how it works. So let's try to import another library from Spacey, another module from Spacey. So from Spacey, let's import, uh, Displacey. Import Displacey. Okay. And then what do I have to do? Displacey dot serve. I think the syntax is correct. And then type in the doc, And then let's define the style as the dependency. Dependency. So if I run this piece of code here, okay, yay, it worked. So you can see here clearly, so what's the relevance or the connections of words with each other? So for example, want is a verb, but it is the nominal subject of I. Okay, so you can see it's easy to see here that the focus of the sentence is the word I because it's the branch, it's the root of all things in the sentence, right? It's like actually there are two roots here, the want and apple. So clearly, if you can like identify these two factors here, you can compress the sentence and identify the meaning already that, okay, the meaning of this sentence is just one apple, because it contains a lot of the connections already, the base connections already. Okay. So that's how mathematicians and like NLP engineers extract meaning from sentences that are like smart and not only like rule based. Okay. So but you need to stop running this one. Um, so it's still like rendering forever. So you can stop running it. Let's stop running it, and then let's proceed to other relevant things. What do I need to teach you? Okay, so let's play. Let's try to like give you guys some challenge. Okay, so let's try to do entity recognition. So let's try to do entity recognition. Recognition. Okay, try this challenge. So for example, I have this sentence. So doc is equal to NLP. Um, let's say the firm. Okay, the firm earned. Let's say 1.5 million in 2017. Okay. For example, we have this sentence. Now, sometimes when you're doing NLP or you're doing like text analytics or text processing, you just want to get information right off the bat, right? So for example, I know that this sentence says has have money. I want to get all the money, the monetary values in that like prose in that sentence. So you can apply NLP to do it. Sometimes it's easier to do it in regex, so regular expressions. You can also do that. But the problem with regex, it's too strict. It's not really smart because it's just looking for certain patterns. Okay, the good thing about NLP is you can do some statistics, but it can also be done in regex. But let's try to do it in Spacey and how you can detect certain entities. For example, in the sentence, I want to extract this term here. Okay, so I want to extract that. Okay, so to do that, let's first define this is a phrase, right? This is a money phrase. So let's define a phrase, an empty phrase first. Then let's define a for loop. So for token in doc. Now, let's make a conditional. So if the token.tag is a dollar sign, because I'm assuming that we already know that the currency is dollars, let's get the phrase. So let's get it, okay? So let's get the let's get that. So how do I get that? Yeah, I need to use phrase. Phrase is equal to the text, the word itself. Let's get the word itself. So this is it, this one. We're getting this one. So token dot text. And then after that, I need to append my counter because I need to, I just got this one, right? Because it's a symbol. I need to get this one. So to get this one, I need an iterator. So token dot I plus 1. So we can get the other index. And then while doc I dot tag is equal to um, what is the identification in spacey of a number? So let's check. So spacey dot explain. Huh, let's try this one. CD. Cardinal number. So okay, it should be cardinal. Actually, I'm not really sure. So I'm gonna Google it, guys. I'm gonna be honest, guys. As a programmer, I don't memorize. I just like Google a lot of things. So, to help you as well, like navigate if you're like looking for some errors, just type spacey, um, spacey linguistic figures. Google is your friend. So let's just try and get help from Google. So yeah. So you can see here the documentation of space. It's very clear. Like all of the examples, I think that I even like showcase it's here. Even the definition of like the text, the lemma. I don't memorize this. Like I always like look like what syntax could I use. For example, what is VBZ? It's always here. Um, it has some discussions already about like morphology, statistics, and so on. So I would suggest that you go over the documentation. Yeah, it's an important skill of a data practitioner that you always consult the documentation for the code or the library that you're using because it always contains the answer. So in our case, I think or FCD. CD, yeah, it's correct. It's the cardinal number. So it's the correct thing that I need to use for it. Okay, so I think I have my answer already. So this would be CD. So it should be a cardinal number. So if I find the number, I need to append my string. So phrase, I need to append it. So plus equal, and then I need to append that. So doc I dot text, and then so I get this already. I get these two terms already, but I need to get the units. So to get the units, I need to, what do I need to do? I need to add a space. So it would be like prettily printed. Then after getting the space, I need to iterate once more. So iterate once more, and then get the next word. To get the next word, phrase is just phrase plus one. So this should be correct. So phrase, how to slice in Python, just get this one. And then print, da, 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 da. What do I need to do? Print phrase. Okay, if I run this code, it worked. So basically what we're doing here is we're iterating over the sentence. We're finding certain indicators of money. So for example, dollars. I find the money already. Then I get that symbol. Then after getting that symbol, I add to the iterator to get the next term, which is the number. So I get the number. Then after getting the number, I added the space. And then after adding the space, I get the units for this one. Okay. So that's how you can do it. So again, I'm going to give you some time to follow along through the code. Okay. What else? Okay, I'm gonna like just copy this code and just demonstrate how you can scale this because I truly believe that this is better than regex. So for example, if I have like more than one item that I need to extract. So for example, I'm gonna like add something to this sentence. So for example, in comparison with give me another number, dollars, 1.2 million dollar in comparison to 1.2 million in, let's say, 2016. Okay, so if I have this sentence, now I want to extract, if I run this code here, it worked. Why did it work? See, it's very scalable as long as you are following this pattern. So as long as you're following this pattern, it will extract those values for you, right? So that's really like cool for this type of thing. Okay, so I think we're already done with that. I need to demonstrate on how you can apply. Okay, let's try some mapping problem. Um, Another visualization demo that I want to uh, tell you is this one. Okay, so for example, let's define another document. So NLP, then I want to fly to Manila again. So I want to fly to Manila. I want to fly to Manila, and then let's try this one. Um, I just want to demonstrate the entity recognizer in Spacey. So space from Spacey, import this Spacey. I have typed this already. So let's try HTML. HTML is equal to this Spacey dot render. Let's render the doc. And then style. So let's get the, what do we want to get? We would want to get the entity, so ENT. And then page is equal to true. So I would just want to use Jupyter Notebook to load it for me. Then I call this place key, type in, I need to import HTML. I'm missing a library. I need to import another library to use to display my HTML. So what library is that? So from IPython, I think it's IPython. Okay. IPython, um, IPython.core.display, import display. Ayan. Yeah. Display and then HTML. Let's try this one. So not display C. Display. This should be display C. Display C, but render HTML. Let's render that HTML. I think this is correct. If I want to visualize like all of the entities in this sentence, for example, if I shift enter, see, it will recognize and render that, okay, Manila is a GPE. So what is a GPE? So again, I don't like memorize it, like GPE, spacey dot explain what is GPE. Geographic, political, something, something. So GPE, it's countries, cities, and states. Okay, that's good. That it's recognized. So for example, if I run, what I want to run? I want to fly to Manila and Singapore, for example. Okay, it recognizes both of them. For example, I want to buy an iPad. Oh, is it an entity? Is an iPad an entity? I'm not sure. I want to buy an Apple computer. Let's see if it recognizes it. Okay, so it recognizes Apple as an organization. Okay, so let's check if it's an, what's an org, if it's really an organization. So it's companies, agencies, and institutions. So cool. So that's how you can like call and visualize the entity recognizer in Spacey. So you just use the attribute. And again, if you want to explore on this, just go here in the Spacey documentation. So it's really like fun to like look at other like things that you can play around with this one. I have already like demonstrated with this like sentence. There are many examples here that you can already play around. Okay. One thing that I would also would want to demonstrate would be similarity. Yeah, for example, how does like the computer know that, for example, apple is related to banana? So for example, let's play some, we call it similarity. Okay, so how do you do it? How do you do it? So for example, NLP, let's define apple dot similarity. Just call in the argument similarity. So what topic are we discussing now? This is word embeddings, word similarity. Similarity. Okay. For example, I want to see how similar is apple with banana based on the dictionary that we're using. Remember, I am using the large dictionary or like the large like stat models NCore Web LG. So if I type in banana, it says that it's 50, no, it's 58% similar. So that's really like a good metric if you would want to like compare things. Like for example, king and queen. Like it's a common like NLP like example that they use. How is like a king and a queen similar to each other? King and queen. Okay, it's really like close to each other because they are like very similar. They are very similar context. So this is cool, right? So for example, if you have two similar words together, you can use it to identify affinity, meaning. So for example, I can get the meaning of this word based on this word. That's really like effective. So to avoid redundancy as well. So for example, if you're analyzing text, you see that, okay, these sentences are just similar. So I can just like combine them into one. So things like that. So yeah, okay, I'm gonna give you like another example about like similarity. So for example, we have like um sige, let's use the example a while ago. I want a green apple. So for example, if I want to get the similarity of 0, 1, 2. So okay, I want to get the similarity of this sentence. I want a green apple and the phrase a green apple. So how do I do that? So I use um, doc. So the whole doc, I want to get the similarity, similarity to doc. Then I'm gonna slice this one. So what's this? So 0, 1, 2. So I start with 2 to get the phrase a green apple. Then 2, 3, 4, 5 plus 1. So it's n plus 1. So 2 to 5. Okay, so if I get the similarity of this document, shift enter, I get 88%. So that's good. What if I want to get the similarity of the sentence to itself? So for example, doc dot similarity. Theoretically, the answer should be 1, right? You're just getting the similarity of the same sentence. It's autocorrelation. It's getting the similarity with itself. So yeah, that's good. Okay. I think that's all for the coding session for today. We need to continue for the next topics on Friday about topic modeling and even sentiment analysis and how you can visualize those things through word clouds or even heat maps and the topic modeling bubbles. Okay, we'll do that on Friday. But for now, I think this is already enough introduction for you to be accustomed and familiar with the syntax that we use in Spacey for basic natural language processing tasks. Okay, again, my comment for you guys is to really like read the documentation. All of the things that I showed you, I don't like memorize the syntax. It should be here. You can find, for example, the vectors and similarity. So this is an example of like the banana. Oh, wait, there's an example here. Yeah, so all of the things that I was mentioning, you can find it here. There's are like documentations here already, and they have recommendations on how you can like visualize the things that you're producing and so on. It includes recommendations of the libraries to use as well. So you're not like only constrained with the two dictionaries that I gave you. There are so many dictionaries out there, like from Wikipedia, from like Twitter API that you can use to train your models. But again, this can be reserved as a reading exercise and a research for you guys. Um, there's a question. It's an interesting question. Is it normal that my similarity for the same code, apple versus banana, is different from your values. It's normal. One, because maybe we're using we're using different dictionaries. I'm using LG and you're using SM. And even though we're, for example, if we're using different we're using the same dictionary, remember that the models that we are using here are probabilistic. So there are certain degrees of error. So it's normal for you to get different values, but it should not be too far. Okay, so it's normal that you don't have the same values as I have, because again, these things are probabilistic in nature. We're using statistical models to develop the word embeddings and the matrices for the words. Okay, I think we can start entertaining questions, but what can I recommend for future reading? For future reading, you can also like explore 2 minutes, 2 minute papers. So you want to read on like yeah, you want to like watch relevant advances in NLP. You can follow this YouTube website, 2 minute papers. Have lots of cool um, visualizations about recent papers on NLP. And also, if you want to ramp up again your statistics because it's relevant to how we understand NLP, I would recommend you guys going to like Seeing Theory. So it's a good resource for you to understand and study statistic concepts visually. So it's fun. For example, if I want to like review my variance, chance events, and so on, it's a great visual way for you to like test even your review of like probabilities and so on. So you can like review your central limit theorem, equations of the variance in terms of cool like examples. There are a lot of topics here, so even regression analysis, probability distributions. If you want to check that out, definitely check this website out from the Brown University. It's really like cool. Let's generate some Gaussian distribution. Generate some Gaussian distribution. Yeah, you can see, yeah, some cool concepts on how you can apply these things. Need to generate more points to have a more accurate fit. There you go. Better fit. Okay, I think we can start answering some of your questions already. Questions from you guys. What does NLP dataset looks like? So if you go over to this one, where is it? Vectors and similarity. So it's similar to like this one. So it's just like composed of like random, like seemingly random numbers, but it's just like a vector. So for example, for the banana dot vector, if you want to check it, so a banana, here's is what like a computer, here's how the computer interprets a banana. It's just like an array of numbers. Okay, I hope that answers your question. Um, will I be able to go through this workshop with only basic Python knowledge? It depends on how you define basic, but again, for NLP, you need at least to know list comprehension. You need to know conditionals. Yeah, just basic Python syntax is enough. And I think there are many resources that you can use already to learn those things, like Free Code Camp. They have like amazing tutorials already for it. Um, what else? Is NLP related to deep learning? Of course, some of the libraries that we use, Spacey. If you look at Spacey, like how it's developed, it's actually already like based from, um, it's already like based from deep neural networks already. Okay, models and language. Where can I find it? So here's like a list of language that you can play around with. Again, it's in the documentation. So you have these languages, you have this like pipelines and even dictionaries. Yeah, you can test. Is there a way to automatically retokenize common terms? automatically recognize common terms. I think the best way, it's not practical to do that, because you will have like a lot of things. I think just find a library that does it for you, because most of the libraries are already able to comprehend certain tags. For example, places. Most of them are able to like identify, for example, People's Republic of China. It's no longer like individual words. It's already like considered like one phrase already. So my suggestion is that you find a good dictionary out there. You can also like use Wikipedia to train it, because in Wikipedia, occurrences of those phrases are always like they're together. So I think that would be like my suggestion. Just find a good dictionary to load in your NLP. Okay. Let me check on other questions. Okay, I'm gonna share this link. Some of you are asking for this one, so I'm gonna send this one. Oh, one more thing. I like this website as well. Papers with Code. So for example, it publishes, yeah, papers with code. So you want to get like updated with the latest machine learning models for NLP, it's also in here that you can find it. Okay. So for example, like image processing, NLP, um, yeah, you can find it here. The papers that you can read, and the code is already like available. So this is a very like cool resource that you can um, also use. I have a question from our audience. Um, what's this? What do you think of fast text? Yeah, I think it's a good. It's also from Python. Again, I'm using Spacey because it's just for an introduction. But definitely, if you scale, fast text contains a lot of vectors already pre-trained. Like they have, I think, 157 languages that you can like play around with. And it's really like efficient for text classification and representation learning. So it's good really for like testing out and training. Okay. So you mentioned things like CNN. So another question is, you mentioned things like CNNs and LSTM. What's the relationship between this and Spacey? I'm not sure what Spacey is actually like a trained model or what. Spacey is just a library that you can use to like uh, do some NLP tasks, but it's not really the one that you use to train it, because you use models to train it. It basically um, trains models. But yeah, I'm gonna search in the documentation how it does that. So let's try to search Google. So Spacey learning algo. So let's see what types of algorithms do they use on the back end, because I'm not entirely sure then. One second to understand this one. Well, yeah, that's a good thing. No, I think it's not really like explicitly labeled here, because the applications of, for example, LSTM, it's usually used for like time series with memory. So I think I need to double check on that. I'm not particularly sure like what exactly the algorithms used in Spacey for that models. But I think it's not really with Spacey, but it's with the model that you're using, the library that you're using. And I think it's not really with Spacey. But again, take it with a grain of salt, because I'm not entirely sure. Okay, have another question here. Referring to slide 71, is this the general recommended NLP processing steps in AI? Okay, I'm gonna share my screen. Let's look at the slides. Slide 71. So I assume that this is it. Okay, yeah. I think this is a good pipeline that you can follow. This is a good way. Just tokenize first, then after tokenizing, lemmatize. After lemmatize, so you have your base words already, then identify. So the tagging and parsing will help you to identify the meaning or the context of those phrases or words. Then after that, you can do entity recognition to supplement that. Common applications of this pipeline will be making a chatbot, or even in topic modeling for Friday's class. So this would be like, even in the class that I do, this is like my recommendation. So I'm not sure if I'm sharing my, oh no, I'm not sharing my screen. Let me reshare my screen. One moment. I think I found like a good answer with how they use NLP in terms of deep learning algorithms in Spacey. So here's like one of the answers. So Spacey has its own deep learning library called Think, and that they use under the hood for different NLP models. So you can read it here. I'm gonna send over the like link that I found in and again, Stack Overflow is the savior. If Stack Overflow crashes, I will no longer have a job. So I'm gonna be poor if Stack Overflow crashes. So it contains every answer. So if you can contribute to Stack Overflow as well, because it contains good like answers to like most of our common problems. Okay. So yeah, so you can find here that it uses transformer architectures in its model, and the backbone of Space is indeed using deep learning libraries. Okay, so you can like research more about Think. For example, you can check the code behind it since it's open source. So it uses PyTorch. Not only PyTorch. Yeah, it's Fast API and Prodigy. Cool, cool. Okay, I need to answer more questions. Spacey better than GenSim or NLTK? I think it's not really like better. You can use them together. I usually use them together because there are some advantages of like NLTK and GenSim. GenSim is good for topic modeling. NLTK is good for the idea that I mentioned a while ago, the Zipf's law. So top NLTK is good. It has sentiment analysis as well. So NLTK has that. So you can use it in conjunction with each other. So that's the good thing about open source technology. You can mix and match these things. Now, even for me, like I use, for example, in machine learning, I use both PyTorch and TensorFlow. So it really like depends on the problem that you're solving. Is it possible to apply NLP models to constructed languages like Minions, Lord of the Rings? Of course, there are already like articles on that on Medium. So like explore articles on towards data science. They have already like tried doing those kinds of explorations. But I think that that's really like interesting because when I was doing my research in university, one of my colleagues is doing NLP research on the Bible. So basically, what she was doing back then in her PhD is that she is extracting the meaning of the verses in the Bible and how it is connected. For example, there are some texts in the Old Testament that are connected to the New Testament. So that's really cool that we can extract meaning from the verses that are not explicitly like inserted there, but the algorithms were able to find it out because the relations to other texts. Okay, so will you put your slides and code for Friday on your GitHub also? Oh, yeah, I will. I will. Sure, sure. Again, I'm all for open data, open sourcing things because if we make things open and available for everyone for free, we can innovate better. And I think the future is open innovation. The future is collective and collaborative innovation. So the more of us like learning from each other, helping each other out, like that would be like a reason for like producing a better world. Okay, I think yeah, we have some more time for questions. I have more questions. Share the link now. Think GitHub. Okay, sure. This one. These are the algorithms behind Spacey. Yeah, but for Friday we will be discussing NLTK and maybe even Jensen. Yeah, I think. Yeah, we can. How do we do NLP on TensorFlow then? Does Spacey replace it or complement? Definitely complements it. Remember that TensorFlow is optimized for machine learning applications and NLP banks on machine learning. So again, TensorFlow can be used to like supplement if no TensorFlow. Why TensorFlow? I think PyTorch is better because as well we can read the documentation, but you can read here that yeah, the algorithms behind Spacey yeah, allows PyTorch and TensorFlow. But if you want to integrate it again, what applications to use machine learning? That like even TensorFlow, that should be clear first because for me, I will use machine learning for segmentation and prediction. So if I'm gonna use my NLP in line with those things, then that's a good option to integrate Spacey to TensorFlow. Okay, but it should be clear first, like what type of machine learning project do you want to use your NLP with? Okay. Another question: is there any other tools you would recommend for analyzing or processing NLP projects? Um, NLP, yeah, I think most of the things that I do for work. Give me 1 second. I'm gonna pull out that slides. Um, yes, yes. Let me pull out my slides. Okay, I'm having technical difficulties. Yes, yes. I hope you can see my other screen. So for NLP, this is what I use for NLP and computer vision. So I use this in conjunction with each other. I'm not sure if you can see it clearly, but I hope you can. Okay, so here are some of the tools recommendations like that I even use for other like problems. So for programming, I mostly use like Python and R and JavaScript. Of course, if you're like doing cool visualizations in D3 and so on. For data visualization, I use these tools. So you can like screenshot your computer so you can have these tools. And again, I can like go this through for Friday's session as well. So for data visualization, I used to use like Dash, Plotly, Shiny, Bokeh, Seaborn, MATLAB. For math and stat, it's usually like Pandas, NumPy, SciPy. For big data, Spark, of course, Databricks, Hadoop, PySpark, and so on. For ETL, I I forgot to include MongoDB, but I stand MongoDB, MongoDB the best. So for machine learning, it's usually scikit-learn and Prophet. For NLP applications and AI, that would be Spacey, NLTK, OpenCV, PyTorch, Keras, TensorFlow, and so on. For deployment, it's Heroku, Streamlit. For network theory, if you have some advanced math with you, you can use Network X, Neo4j, and Gephi. Yeah, and I think that's it. All right, I think it's already time. We have consumed a very productive 2 hours. I would like to thank everyone for joining us for this session. I had a blast like sharing something. So I hope you learned something from this session. And see you some other time. Hope to connect. Please feel free to connect with me through my LinkedIn account. My name is Albert Umol. So add me on LinkedIn, connect with me. Find if you want to like collaborate or like ask some tips on the data industry in the Asia Pacific or even like some gigs that you want to like find overseas. Please do. And again, if you are interested to join our data clubs in Esquelabs, visit our website, esquelabs.com. We have some cool offerings in terms of how we teach data science and how we teach um, um, artificial intelligence, machine learning for social mobility. Again, thank you so much for having me. Take care, everyone. Hope you get vaccinated. Hope you get vaccinated soon, so we can go back and enjoy the world together. Thank you, guys.